Boarding the International Space Station is not just an honor for astronauts from around the world, but an extraordinary adventure.
You're shot into the air in this sort of missile, a giant explosive device 53 meters tall.
Most people can only dream of traveling to the stars. But for this man, it's a dream come true. He's about to share his experience in this exclusive interview.
Are you filming? Action.
The challenge of living in weightlessness. How he slept, stayed healthy, oriented himself, kept in touch with his family, carried out his obligations, and marveled at the sight of our planet.
Another thing I loved doing up there was taking pictures of the Earth. I took 245,000.
These space professionals will tell us all about their most recent mission.
I was worried about having to go 6 months without a shower.
The lemonade that you drink yesterday is the same that you drink today and the same that you drink tomorrow.
Being in microgravity, it's kind of extreme for the body. The muscle mass is decreasing and also the density of the bones.
By subjecting their bodies to unearthly phenomena and performing hundreds of experiments, they're contributing to a common goal: scientific progress.
We say it's about observing the unobservable.
We can do a lot on Earth, but the one thing we can't do is eliminate gravity.
But how did this immense structure, which has been inhabited for more than 20 years, come to be? How does an international coalition of thousands of men and women achieve such an astronomical accomplishment? And finally, how do the astronauts suit up to face the dangers of space?
Spacewalks are very physically demanding, like boxing.
Closing your hand to grasp a logbook is like squeezing a tennis ball.
At any time, there could be a breach in the hull, or we could crash into a meteorite. Anything can happen.
Now, these astronauts, joined by scientists, physicians, instructors, and directors, and aided by computer-generated images, will give you a behind-the-scenes look at how a mission on the International Space Station unfolds. Prepare to launch on an extraordinary voyage with one of the world's most accomplished astronauts. This is Mission Alpha, Exploring Life in Space. April 23rd, 2021, Cape Canaveral, Florida. Thomas Pesquet is preparing to leave for his second trip to the International Space Station. He's headed to the rocket developed by SpaceX in collaboration with NASA. He'll be joined on this mission by American astronauts Shane Kimbrough and Megan MacArthur, the commander and pilot respectively, and Japanese astronaut Akiko Oshide.
And we got some really cool views of the second two astronauts walking through the crew arm.
This is the third crew to leave Earth with SpaceX, which was founded by Elon Musk. In June 2020, NASA gave permission to reuse rocket launchers and capsules. The Crew Dragon Endeavour C206 is the first to be reused for a manned spaceflight. It has already flown once before in May 2020, when it carried Americans Douglas Hurley and Robert Behnken to the ISS.
Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, bottom dog.
They were on the ISS for 64 days, traveling there and back in the same capsule.
There'll be a few more call-outs here.
Thomas and his crewmates are now seated in the same cockpit, ready for one of the most critical parts of any space mission: takeoff.
3, 2, 1, 0. Mission. And liftoff. Godspeed, Endeavour, and Crew 2.
Copy, 1 Alpha.
Endeavour launches once again. 4 astronauts from 3 countries on Crew 2. Now making...
And they're off on a voyage that will last over 195 days, or more than 6 months, to the International Space Station, also known as the ISS. This mission, known as Alpha, will once again offer the 4 crew members a chance to experience a unique adrenaline rush.
The second time, you know what to expect. We were euphoric. My colleagues and I were laughing and high-fiving each other. We were really happy.
During takeoff, the rocket is constantly accelerating. At an average speed of 5,000 kilometers per hour, moving in a straight line, it would take less than 5 minutes to reach the 400 kilometers of altitude of the space station. But at that speed, it would be difficult to accurately navigate to the ISS, which orbits the Earth at 27,600 kilometers per hour. So instead, the rocket quickly shifts to a curved trajectory to move around the Earth. 2 minutes and 40 seconds after takeoff, the first stage of the rocket, an enormous engine, breaks off. Then, a second engine kicks in to put the Dragon capsule into orbit. For this mission, the first stage will descend back to Earth and land on a platform in the middle of the ocean, where SpaceX will recover it and repair it for future use. 10 minutes after launch, the second engine turns off and attaches in turn. As it enters the atmosphere, it burns up and disintegrates like a shooting star. And a little while later, a small point of light appears in the middle of space like a UFO, the International Space Station. Thanks to this project, unlike any other in history, humans have been present in space since July 2000. NASA came up with the idea in the 1980s, and the project was brought to fruition thanks to an important coalition between the United States, Russia, Japan, Europe, and Canada. In November 1988, the first Russian module, Zarya, was put in place. Next, the International Space Station was assembled like a series of building blocks, which are infinitely modular and still evolving today. There are 4 main sections. At the back of the mechanical giant is the Russian part, which is composed of the first modules to be sent into space. In the center, the core of the station is composed of Unity and Tranquility, 2 hubs to which several other modules are attached. At the front, the American, European, and Japanese laboratories are connected to one another. These 3 pressurized sections provide a 51-meter-long habitat with a volume of 388 cubic meters, the equivalent of a 155 square meter house. The 4th section, which is not inhabitable, is this immense structure 188 meters long. It consists of a massive beam outfitted with solar panels, radiators, and a set of rails that the Canadian robotic arm moves up and down on. The International Space Station is the size of a soccer field and weighs 450 tons, as much as 22 buses. It's the largest man-made object orbiting our planet today. At first, 3 people lived on the ISS at a time. Starting in November 2009, it was 6 people, and there have been 7 since 2021. Each astronaut spends between 3 and 6 months on board, and they split their days between performing assembly and maintenance tasks and conducting scientific experiments. The ISS was designed first and foremost as a laboratory to conduct extraordinary scientific research. Once the Dragon capsule is in orbit, the 4 astronauts inside no longer feel the gravitational pull of the Earth. They continue on towards their goal of docking with the enormous structure floating in front of them. There are 2 ways for the capsule to attach itself. Docking, which involves a slow, careful approach to the station followed by a direct connection. The second is berthing, during which the capsule approaches the side of the station, then the ISS's robotic arm grabs onto the capsule and attaches it to the station manually. It takes anywhere from 3 to 48 hours to complete the docking process. With the capsule orbiting the Earth once every 92 minutes, the docking of the Alpha crew, which took 23 hours and 30 minutes, was completed over the course of 15 orbits and just as many sunrises and sunsets.
Going to space is a series of small miracles, or big ones, actually. There can't be any technical errors, which is already significant. Keeping the space station in operation requires numerous launches and supply runs. It seems easy, but it's an ongoing challenge. It takes a huge amount of work on the part of hundreds, even thousands of people. And there's always a risk that something could go wrong during the launch. There could be a breach in the hull, or we could crash into a meteorite. Anything can happen.
Endeavour arriving.
On April 24th, 2021, at 1:45 in the afternoon Paris time, Megan, Shane, Aki, and Thomas arrive on board the International Space Station. They're just 4 of the 260 people who have spent time on board the ISS, and the more than 500 astronauts who have crossed the legendary boundary of space at 100 kilometers of altitude since Yuri Gagarin in 1961 and the men of the Apollo missions.
That's one small step for man, one giant leap for mankind.
They head to a hostile environment, an incredible adventure during which they experience things most of us couldn't even imagine. Traveling and living in space. A thin layer of metal is all that separates the astronauts from the interstellar void that surrounds them. To keep them alive, they're provided with some 15 pressurized modules equipped with life support systems. In order for the astronauts to be able to breathe inside, they need oxygen from outside, which is transported in gas tanks that are recycled as many times as possible. The station also needs regular deliveries of water, although 80 to 90% of it is recycled today. Moisture in the air, drying towels, and the air we breathe out results in condensation, which is purified and recycled. But the liquid that is reused the most is urine.
The lemonade that you drink yesterday is the same that you drink today and the same that you drink tomorrow. And you also drink the lemonade of your crewmates, so it's an interesting concept. So we try to be as efficient as we can. Again, we are not completely closed the loop yet, so we still need to bring up about 10 to 20% of the water.
With all this water they have available to them, they're also able to take care of one thing that's essential for cohabitation: personal hygiene. There are obviously no showers on board, as water in the air could damage the electrical system.
At first, I was worried about having to go 6 months without a shower, but we actually managed to stay very clean, despite getting 2.5 hours of exercise a day.
For washing, the astronauts are allotted 300 milliliters of water to wet a towel with eau de toilette and hot water for washing, then another one for rinsing. If necessary, wipes are also available for more localized cleaning. Planning is essential on board the ISS in order to coordinate the astronauts and their various schedules. They all follow Greenwich Mean Time, UTC-0, for practical reasons. And the astronauts have very strict schedules for their busy days of work.
The astronauts wake up between 6 and 7 in the morning. There's a morning briefing with the whole crew present. Then they split up to conduct their various experiments. They each have their own schedules. Between scientific experiments, station maintenance, whether it be computer-related or cleaning the filters, they also have to fit in their training sessions, which add up to around 2 hours of physical activity per day. They each have a short lunch break between 12 o'clock and 2 o'clock, not all at the same time. Then they finish their days at 6 or 7 in the evening. After that, they have free time. Saturdays are usually for maintenance, and they have Sundays off.
But resting on board, with the constant hum of the station and the succession of 16 sunrises and sunsets per day due to their constant orbit, is nearly impossible for Earth dwellers like us. To make it easier on the astronauts, they each have a small bedroom, no larger than a phone booth, where they can keep a few personal belongings, a computer to communicate with Earth, listen to music, or sort through their photos, and a special sleeping bag attached to the wall. There's no need for pillows in these unique beds, because in a zero-gravity environment, the head doesn't need to be supported in order to relax.
The feeling of floating can be unsettling at first, because you're not resting on anything. You can't feel a bed underneath you or a blanket or comforter on top, and your head isn't resting on a pillow, which is kind of ingrained in us because we've done it our whole lives.
Yet these moments of rest are necessary to keep the astronauts healthy, for 6 months of weightlessness are hard on the human body. In weightlessness, the spinal column stretches out and the body grows a few centimeters. While in the absence of gravity, fluids float in suspension. Fortunately, inside the astronauts' bodies, their blood continues to circulate thanks to the pumping of their hearts. But it circulates differently, as it's no longer subjected to gravity, so it focuses on the most vital areas of the human body, the torso and head. This causes the astronauts' legs to get thinner, while their faces grow slightly puffy. Their hearts shrink and their red blood cell count goes down, because their bodies consume less energy. Because of that, their muscles atrophy and their bones lose calcium.
Being in microgravity is kind of extreme for the body. It's something that we've known from the, let's say, early era of spaceflight, that the muscle mass is decreasing and also the density of the bones. First of all, we check the bone density of the astronauts during their selection. And then we check that also just before the mission and once they come back. We know that it's not irreversible up to the point that we have exposed humans.
To avoid losing too much muscle or bone mass over the course of their mission, the astronauts must engage in physical activity several times a day.
The recommendation is about 2 hours of exercise per day. So we have 3 exercise countermeasures on the International Space Station. We have a cycle ergometer, a treadmill, and let's say weightlifting. Of course, it's not real weights because there is no gravity, but you actually work your body against some resistance. And that is actually very important. It complements the other 2 to maintain your muscle and bone density.
These exercises are also important in case they need to return to Earth earlier than planned.
We could have to come back unexpectedly in the event of a fire or depressurization. If we were to land in the taiga, we could be attacked by a bear. Who knows? So, to stay in shape, we train our muscles. We force ourselves to exercise to ensure we'll be in good shape when we get back to Earth.
Exercising isn't the only thing that's different in space. Every movement, every part of their daily routines becomes an adventure. It's difficult to get rid of the reflexes developed down on Earth.
When you're on the space station, if someone asks you to pass them the screwdriver, you just float it gently in their direction. You don't throw it in their face. You just give it a gentle push and they'll catch it. It's very handy. But at first, people continue to take gravity into account when they throw something. On Earth, if you throw a ball or a screwdriver, it will eventually fall to the ground. But on the space station, if you throw it like you would on Earth, the screwdriver would go 1.5 meters over the person's head. When it's someone's first time up there and they haven't gotten used to it yet, they're always throwing things 2 meters over the heads of the people they're throwing to. It's funny to watch.
But humans are quick to adapt to their new environment.
I love floating on board the ISS. It's great. It's funny, floating is kind of stressful because there's a loss of control. You have to accept that your body weighs nothing, and you aren't the same person anymore. You just float. I think it's great because it frees you from the usual constraints of the human body. Whenever I move, I tend to spin around a lot. I like bouncing off in different directions and all that. I love being able to move around in 3 dimensions like you would in a dream.
The astronauts generally stay on the International Space Station for around 200 days at a time. But they're far from independent while they're up there. Ground support is essential for planning supply runs, designing tools, testing tasks, helping the crew with complex operations, monitoring the various functions of the station, maintaining communication, and coordinating all the different parties. There are many agencies, organizations, and groups around the world involved in each of these tasks. NASA may be in charge of coordinating the astronaut schedules with agencies from around the world, but the European Space Agency oversees what happens in their lab, the Columbus. Scientific experiments are conducted here in this module, right next to where the Crew Dragon capsule docks. At 6.9 meters long and 4.5 meters across, with a mass of 10 tons and a weight of 300 kilograms, it's smaller than its Russian, Japanese, and American counterparts. It's even smaller inside because they installed a square space with a cylinder in order to be able to store more things inside the walls. Thomas will spend much of his time in this lab, which has a surface area of 15 square meters and a volume of 45 cubic meters. He has plenty to do while he's on board, overseeing nearly 200 experiments, 40 of which are for Europe. The control station for the European Columbus module is in Germany, not far from Munich. This is the control center for this laboratory, unlike any other, orbiting the Earth 400 kilometers above our heads. The USA, Russia, and Japan each have their own laboratories on board. But NASA is in charge of coordinating the station as a whole and communicating with the various nations, as each country has usage rights to the other modules. Nearly half the usage of the Columbus module is ceded to NASA in exchange for transport. As a result, it's not uncommon for astronauts to find themselves conducting experiments in labs other than their own. NASA can ask to use the Columbus, just as Thomas can be sent to work on Destiny, the GEM, or the Nauka, the American, Japanese, and Russian labs, respectively.
Primarily what we do here is we operate the Columbus module itself. So all the main systems of the module, life support, power, communications, and we have connections to the USOCs, which are the science operation centers around Europe where the science is actually performed.
Inside the Columbus, everything is stored on racks containing a multitude of scientific instruments. There are 16 in this module, 5 of which are equipped with specialized tools.
We have what we call the Fluid Science Laboratory, which is a laboratory where we do all the fluid science in microgravity. So study, for example, about how the gas and liquid interact together. We have the electromagnetic levitator, which study, for example, the way metal alloys melt and solidify. We have the European Physiology module, which is the one used for studying human physiology, and so medical experiments typically. So basically are like an hospital.
This extraordinary equipment makes it possible for the astronauts to carry out their primary task, scientific experimentation.
We can do a lot on Earth when it comes to scientific experiments. We can control the luminosity, the temperature, the pH, and the gaseous composition. The one thing we can't do is eliminate gravity. But we've realized that in the absence of the gravitational forces of the Earth, we can observe things that are normally hidden.
For example, the way two liquids mix on Earth is subject to gravitational forces. Heavier liquids automatically sink underneath lighter liquids without mixing. On the ISS, molecules can be observed acting differently. To supervise these experiments and assist the astronauts, several teams work 24/7 at the operation and control centers on Earth. In the south of France, near Toulouse, the CNES, the National Center for Space Studies, is home to CADMOS, the Center for the Assistance and Development of Microgravity Applications and Spatial Operations. This is where the CADMOS team analyzes projects proposed by companies, laboratories, and institutes all around the world. They consider the feasibility and the necessity of conducting these experiments on board the ISS.
To observe a specific physical, chemical, biological, or physiological phenomenon, we come up with an experiment that responds to their needs while also adapting to the many constraints of the ISS and the microgravity on board. The experiment must also be conducted by an astronaut who lacks the specialized knowledge of the scientist, at least at first.
The scientists from CADMOS have to consider thermal, optical, electrical, and electromagnetic factors, along with sturdiness, size, weight, toxicity, and the risk of depressurization, fire, and sharp edges. The team must analyze an infinite number of factors essential to the astronauts' survival before they even consider sending an experiment on board. Once an experiment has been selected from the thousands of proposals, it's carefully packaged up and loaded onto a shuttle to be sent to one of the laboratories of the International Space Station. During its time on board, which can range from a few days to a few years, It will be managed and overseen by one or more astronauts from different countries.
We oversee experiments, not necessarily the people conducting them. So if we have a Russian, Japanese, or American astronaut on a European experiment that we're in charge of, we'll manage the operations from here.
The CADMOS team sets up and monitors the experiments, and the astronauts work for the various agencies to ensure the protocols are carried out according to plan, all for one common cause: science. Some tools require more training than others, such as certain medical devices. Thomas has experience with one of them in particular, the ultrasound machine.
Thomas is an engineer and a pilot, but not a doctor, and even less so an ultrasound technician. It takes a lot of skill to manipulate an ultrasound, so it requires a lot of practice. It's much more complex than mixing two liquids together with a pipette, for example.
For the ISS, a new type of ultrasound was invented and developed by the team at CADMOS under the supervision of Didier Chaput.
ECHO was taken on board by the Proxima mission in 2016. It took 3 years of preparation. Once it was on board, the astronauts were able to start using it for different experiments.
There's generally only one kind of each tool on the station. If a country wants to use a specific device for a given experiment or to do a repair, they simply ask the country that owns it for permission. This new ultrasound machine replaced the old one because it's much easier to use. Before, they had to move the probe around and place it in the right location to observe what the doctor wanted to see. Ultrasound images are very difficult to interpret unless you're a trained physician. So, to make the task easier on the astronauts, they came up with a remote-controlled probe. This probe can be controlled by doctors on Earth, who can be much more precise than an untrained astronaut, allowing them to target the exact location they want to observe.
All the astronaut needs to do is hold the probe in place. The experts do all the necessary adjustments. They know where to move the machine, and they can also optimize the position of the probe. Once they have the probe in place, they can save the image for future analysis.
From the control center, the physician can change the settings on the machine and even take measurements using a keyboard that matches that on ISS. They use a joystick to control the probe from thousands of kilometers away.
The command travels from Toulouse to Germany to the United States. Then from the United States, it goes to a relay satellite thousands of kilometers from the station. And from there, the information is sent to the station, and then from the station to the ultrasound machine. After that, it travels back to Toulouse, and the doctors get the results from the ultrasound. All that takes less than 3 seconds.
Thanks to this extraordinary technological innovation, astronauts no longer need to spend time learning highly specialized skills, and experts are able to examine the exact locations they're interested in. There are hundreds of experiments underway at any given moment in time. Remote-controlled objects, blends of liquids, bacteria, the growing of plants, radiation, and technology. Every field of science is represented. The astronauts also act as guinea pigs in experiments on sleep quality, physical exercise, virtual reality, physiology, neurology, and health. Thousands of hours of work go into trying to understand phenomena that are impossible to properly study on Earth. Half of the astronauts' time is dedicated to scientific research, while the other half is spent on physical exercise, station maintenance, and various installations and repairs. But every once in a while, Thomas Pesquet gets a bit of time to himself, and one thing he's discovered he loves is space photography. He has built his reputation by publishing stunning photos from space on social media. The space station is an excellent vantage point from which to observe the Earth, and it's not as far away as you might think. When we think of the ISS, we tend to imagine that the astronauts have a view of the Earth as a whole, like a ball floating in space. But the average altitude of the station is just 400 kilometers, which is the distance between Boston and Philadelphia as the crow flies. If you were to rotate that same distance vertically above Boston, that's where the space station is orbiting above our planet. So, the astronauts don't see the entire Earth all at once. They'd have to be much farther away to have an overall view of the planet.
We see the Earth, but not as a small marble in the distance. We're still pretty close, so we can see the curved surface very clearly. We see a bit of the horizon on one side and a bit on the other, but we only see a few thousand kilometers at a time, not the whole planet at once.
Thomas can now share his photos with the public thanks to the station's own private network. Antennas scattered across the globe work together with the satellite array to send data back and forth and remain in constant contact with the astronauts.
You need to watch for Note 3.
We can't stay out of touch for a whole orbit, so we use the TDRS, Tracking and Data Relay System, which is a network of American satellites that relay signals between the Earth and the ISS.
The great thing about a satellite is you not only get the audio communication, but you also get excellent video. That's how come we can see the astronauts when they're doing their spacewalks.
Based on their knowledge of where the antennas and satellites are located, they can determine the quality of the signal in advance and even predict when it will be interrupted. On the screens at the control centers, a band of color tells agents when the connection will drop and come back during each of the station's orbits. This is essential for planning when important information will be sent and received, or warning the ISS of any possible risk, such as the imminent arrival of a cosmic ray shower. One place where the astronauts are especially vulnerable is outside the space station when they're performing spacewalks or EVAs, extravehicular activities.
We need continuously to maintain the International Space Station. Maintain means repairs on one hand. Some things can break outside of the International Space Station, but not only for repairs, also for upgrades. For example, many of the EVAs we are now doing is to upgrade the solar arrays.
When an astronaut does an EVA, what they do is they put on a spacesuit. But even before that point, they have to get ready. So, of course, there are many years of training down on the ground where they're learning about how to be carrying the spacesuit, testing all of this equipment that might be used in space one day.
They must learn how to use each of these many tools at their disposal before ever putting on the famous spacesuits. The spacesuits are made in Houston at NASA's most famous space center. This is where they take the astronauts' measurements and do fittings of their spacesuits, which weigh 150 kilograms when fully equipped. They're made to measure for each astronaut. Moving is very difficult for the astronauts, whose range of motion is restricted. It would be impossible for them to grasp a tool behind their back, for example. But the part that requires the most mobility and the most adjustments is the fingers.
Closing your hand to grasp a logbook is like squeezing a tennis ball. It's the same for moving your arm. You have to do that hundreds of times in a single spacewalk, which takes a lot of energy.
There's no better way to learn how to use these incredible spacesuits than to put them on and practice. The astronauts are buckled into these massive weighted suits, then transported and immersed in the largest astronaut training basin in the world, where the temperature is kept between 28 to 31 degrees Celsius. This is the Neutral Buoyancy Lab, or NBL, an immense pool 61 meters long, 31 meters wide, and 12 meters deep. It takes 23 million liters of water to fill this 23,000 cubic meter basin, the equivalent of 9 Olympic pools. Because that amount of water exerts so much outward pressure, the walls are 1.8 meters thick, and the pool is half in ground. Inside this basin, the astronauts can practice specific movements such as installing equipment, dealing with technical problems, communicating with their teammates, and interacting with the robotic arm. They spend countless hours preparing for the extraordinarily dangerous activity that is a spacewalk. A complete replica of the ISS wouldn't fit inside this pool. So instead, they created a unique assembly that allows them to fit several modules together. They also installed 2 rolling bridges and 4 crane booms to move around and reassemble the structures depending on the mission. The spacesuits are outfitted with all kinds of technology designed to keep the astronauts alive in the extreme environment of space for up to nearly 8 hours. A life support system with heating and cooling is built into this backpack because the spacesuit can reach temperatures of 150 degrees Celsius when facing the sun and minus 150 degrees Celsius when in the shade. For breathing, pure oxygen is ventilated into the spacesuit, and the CO2 the astronauts breathe out is released into space through a filter.
You have to learn how to live inside the spacesuit. The astronauts don't generally like the spacesuits when they first start training because they're uncomfortable and you're sealed inside them for hours at a time. They rub in different places. The advice we give our astronauts is to love their spacesuits and keep in mind that they're there to protect them from the outside world. They're like a little cocoon keeping them safe.
But in order for the astronauts to get used to their suits, they must spend between 150 and 200 hours in the pool to acquire the dexterity and skills they'll need on a spacewalk. Because once they're in space, everything changes. There are no more 10-meter thick walls, no divers to help them, just them and their crewmates attached to a cable, rotating around the Earth. Leaving the space station is a very intense experience for these astronauts, for space is the most hostile environment we've ever explored.
Spacewalks are very physically demanding. Working on the station doesn't require that much effort. You're floating, so it's pretty easy. Spacewalks are like boxing. Every time you move, you have to fold the spacesuit, which is like an inflatable, pressurized suit of armor, making it resistant to movement. So just trying to move your arm to try to grasp something is like crushing a tennis ball. It's hard work for the upper body. Moving around is like rock climbing in armor.
Rock climbing on an enormous wall traveling at 27,600 kilometers per hour with 400 kilometers of emptiness beneath you. Each spacewalk takes hours of preparation for the astronauts to get into their massive spacesuits, go into the airlock for depressurization, then wait for the moment when the door finally opens.
It's impressive, but at first, all you can think about is the job you have to do and getting it done fast. The first 3 hours, I wasn't really paying attention to what was around me. I was focused on the task at hand. I was 3 hours into my first spacewalk before Shane told me to look around. He said I was a few minutes ahead of him. So maybe I should look at the Earth and take a picture or two, which I did. That's when it hit me, and I realized how amazing it was. You feel like the station isn't moving because you're moving around it like you would on a rock wall. But when you look at the Earth, it feels like it's the Earth that's rolling around like a giant ball underneath you in your fixed reference point.
The astronauts move around the station using a system similar to a via ferrata, with 2 lead ropes equipped with carabiners and an additional safety line that follows them everywhere. They move slowly and methodically as they perform their tasks.
You get used to the safety line too, which unspools behind you. It's good to have a safety line, but it gets caught on everything, antennas and cables and such. As you move around, go behind things, then back up, etc. It can get really tangled up. Sometimes it even winds around your own helmet and you can't reach anything behind you. Your field of motion is here, in front of you. You can't move your arms enough to touch the back of your head. It's impossible. The spacesuit is too big and your arms don't have enough mobility. But it becomes second nature to be constantly aware where you came from, how you got there, where your safety line is, where you're going next, and all that. You get used to it.
This safety line is the last thing connecting the astronauts to the International Space Station. And like in a sci-fi movie, if an astronaut were to lose all contact with the station and find themselves drifting away from the ISS, they would have one last way to attempt to make it back to the station and survive.
We have a little jetpack in our backpack, a little command module, which can be used to stop rotation, aim for a particular point on the station, and propel you forwards. We only have enough nitrogen to do it once. You have to move fast and aim perfectly. No one's ever had to use it, but yeah, it provides another layer of security.
Since the astronauts in the ISS are located so close to the Earth, they're at risk of colliding with debris. Depending on the size, a collision between two objects moving at such high speeds could cause serious damage. All objects more than 10 centimeters across are observed and mapped from the ground.
The station gets frequently hit by smaller objects. And then in case that it's needed, we can perform what we call a PDAM maneuver. It's a debris avoidance maneuver.
So what they do is they ask the mission control to turn on the propulsion system of the International Space Station. Then the space station can move a little bit.
Sometimes we see it too late. It happened once during my mission. It was too late to organize an avoidance maneuver, and then the crew closes all the hatches of the space station and takes shelter in their crew vehicle, so that in case that there would be an impact of the debris and that there would be a real emergency, that they could leave the space station and return to Earth. Luckily for us, the debris passed close by, about 1 kilometer, it's not so far away, but did not hit the space station, and then we were able again to resume our normal operations.
Fortunately, there is rarely a need for emergency maneuvers such as these. The engines are used regularly, however, because the station loses 50 to 100 meters of altitude per day due to friction and the position of the solar panels. The station must remain at an altitude of between 370 and 460 kilometers. If it were to fall too low, it would be at risk of losing speed, falling out of orbit, and being destroyed in the atmosphere. While Thomas was on board, they experienced a very unexpected issue with the engines. With the arrival of the new Russian lab, the Nauka, its propellers were accidentally triggered, sending the space station into a spin.
It took some time for the teams on the ground to be able to react, to be able to command the thrusters to off, and to make sure that the ISS was again in a good attitude to continue its mission. Luckily, the teams reacted very proficiently. Also, the team on board reacted very calmly and very proficiently. So, at the end, no damage was done to the International Space Station.
A situation like this could quickly become a problem if the crew weren't trained, if they didn't work well together as a team, or if there wasn't a pre-established hierarchy on board the International Space Station.
And Thomas, you've been an amazing crewmate, and you're going to be a superb commander. So, congratulations.
After his second mission, Thomas will have spent more than a year in space, 396 days to be exact. It's time for him to say goodbye to his colleagues and return to Earth.
I was happy to leave, because 200 days is a long time. There are certain things you miss and look forward to having again. When you get back to Earth, you can see your family, your friends, food, and nature again. You get everything packed up well in advance. You don't put it off until the last minute and then realize you forgot to do something. That's out of the question. You need to have your mind free to concentrate on the return trip, because it can be dangerous. You have to say goodbye to your colleagues. It's a serious moment, because once again, even though nothing's gone wrong so far, you never know. You all hug, and then the doors close. The doors to the airlock on the shuttle, then the airlock on the station. Then you undock with support from the control center. The shuttle's been empty for 200 days, but it's right there waiting for you.
On November 8th, the Dragon Endeavour capsule separated from the station, with Megan, Shane, Akiko, and Thomas on board, the same crew that traveled up in it months before. Thomas was tasked with one last mission he particularly enjoys before they descended back down to Earth.
We went around the space station, all the way around it, at a distance of 150 to 360 meters, to document and photograph the whole surface of the space station. Not many people get the chance to do that. No one had done it since 2011, but we got to document it. It's important for the team to have a detailed view of the condition of the exterior and how it was configured and all that. It took almost an hour and a half. I took 2,000 pictures.
Once he finished taking pictures, it was time to buckle up for one of the most extreme moments of their trip, a sea landing off the coast of Florida. The SpaceX capsule starts by braking slightly. As it loses speed, gravity becomes stronger, and the capsule gradually loses altitude. As they descend and the density of the atmosphere increases, the capsule slows down even more due to friction, and their trajectory becomes less and less elliptical. After the lower part detaches, air friction increases, the capsule breaks, and the rotation curve becomes almost vertical.
It's the opposite of accelerating in a car, which pushes you back against the seat. We come in backwards because the heat shield is at the back. The capsule decelerates more and more, subjecting us to 3, 4, then 5 Gs. We're completely crushed against our seats, and it's hard to breathe. 5 Gs is bad enough in a normal situation, but when you've been in weightlessness for 200 days, it's really hard. The capsule turns into a fireball. First you see sparks, then actual flames. You're inside a ball of fire, so it's physically challenging. As soon as you've decelerated enough, you open the parachutes and come the rest of the way down with the parachute at 8 meters a second right into the water with a big plop.
Endeavour, on behalf of SpaceX, welcome home to planet Earth.
After that, a large boat approaches and winches us onto the bridge. Then the teams from SpaceX and NASA and the ESA are there to meet us with doctors and everything. They take us out of the capsule gently because we don't want to hurt our backs. We haven't carried our own weight for a while, so we're off balance, and then we gradually come, I was going to say back to life, but no, back to Earth. And then we get to see our loved ones a few hours later, which is great.
Here comes Thomas. It's the ESA doc on board, checking in with Thomas Pesquet.
After his return to Earth and a few tests in Florida to confirm he's in good health, Thomas Pesquet is transported, along with his doctor, Adrianos Golemis, to the European Astronaut Training Center in Cologne, Germany.
We help them, of course, stand if they need to, but it's impressive to see that the body really readapts so fast. Of course, there are effects that take much longer. For example, you'll get your bone density back to good levels pretty quickly, but to optimal levels or your pre-flight levels, it might take a few years, a couple of years actually.
I remember they drew 21 vials of blood after my first mission. My partner was there and she asked, why didn't they just leave me alone? She said I looked really weak and under the weather, obviously, and then they drew 21 vials of blood. It's calculated, of course. The doctors know what they're doing, but you still feel kind of like a guinea pig. You don't feel so good. You have trouble standing up, you're dizzy, and sometimes you can't really walk on your own. It was better after the second mission because my body had been through it once before.
Between physical therapy, personal training, and doctor's appointments, the return to Earth is far from restful. The astronauts are subjected to an intense program of rehabilitation and complete the same tests before, during, and after their stay in microgravity to contribute to the collection of scientific data on the effect of long-term stays in orbit on the human body. Despite having just returned to Earth, Thomas is as enthusiastic and ambitious as ever. After 2 missions on board the ISS, he wouldn't hesitate to return if he were selected again. But he also has other dreams.
The next step is to go to the moon, or around the moon. The space station is the farthest we've gone for now. But as soon as there's somewhere farther to go, we'll all jump at the chance.
The ISS is 400 kilometers away. The moon is between 356 and 406,000 kilometers from the Earth. Depending on its position, Mars is 40 to 400 million kilometers away. Each destination increases by a factor of 1,000. It would take between 150 and 300 days to reach Mars, whereas it takes just 3 days to reach the moon. The farthest from the Earth a human has ever been is 400,171 kilometers during the Apollo 13 mission on April 15, 1970, when they were a mere 254 kilometers from the far side of the moon. Humans are always trying to go farther and beat new records.
We rise together, back to the moon and beyond.
First, we sent just one guy in space for a few hours, Yuri Gagarin. Then we started sending people up for longer and longer and started building larger and larger structures. These days, we have 200-day missions on a space station the size of a soccer field. We think there's a lot to learn about the moon, and it's a major stepping stone and a kind of real-life test for traveling to Mars. But to get to Mars, we have to know how to get around the moon. You wouldn't get on a plane to cross the Atlantic without knowing you can cross the Channel or the Mediterranean. It's impossible.
So, will Thomas Pesquet have the chance to set foot on the moon one day?
I'm dying to go there, just like the rest of my colleagues. None of us would hesitate for an instant. It's kind of a dream for all of us. That's why we're here. We want to explore, to travel as far as we can. We traveled to the space station, but if there were an opportunity to go somewhere farther, we'd jump at the chance. We'll see. We don't know the details of when or who just yet. I'd love to be able to tell you it'll be me, but I don't know. Secretly, I'm dreaming of it, but we'll see what happens.